Hello, everyone. Today I'm here to talk to you about streamlining data exploration using artificial intelligence. My name is Mya. Here's a little bit of information about me. I've been in the industry for about 15 years. I've had a lot of experience both at large companies as well as individual startups. If you want to connect with me on social media, feel free to scan that QR code there and track me down on the platform of your choice. A little context for this talk, I don't focus on the OpenTelemetry side really as much. I've been an end user since 2023. The community provides a great collector process that can be dropped into your infrastructure and start monitoring your tools and services immediately. They can collect information from StatsD, Prometheus, even collect Jaeger traces, and store everything in a database of your choosing. I tend to prefer SQL systems. It just is the thing I'm most comfortable with. And I've seen a lot of great work come from AI and SQL. Tend to be a strong advocate for data privacy and sovereignty. And when it comes to the systems I run in production, I use things like ClickHouse and Postgres. Now, I don't see AI as an end-all be-all solution. I very much see it with a very grounded perspective and recognize that it's not great for things. Over the summer, we had Replic's major issue where a rogue agent dropped their database in production. We saw where Chevy deployed an agent that agreed to sell customers cars for $1. And so I very much look at it for the things that I know it can do well. Automating repetitive tasks, analyzing large data sets when maybe the information is too cumbersome for an individual to take on immediately. Detecting patterns and trends within code. We're all human. We tend to make mistakes, and sometimes we can miss patterns and trends unless we're really looking for unless we're really looking at a specific slice of a data set. And one of the things where I found AI to really help improve my workflow has been making overwhelming tasks more approachable. And Model Context Protocol really helped augment models that I saw trained on old information with newer context and capabilities that weren't around back then. One of the things that I feel like the ecosystem did really well was really focus on the idea of a chat prompt. At first, I was very adverse to using this kind of interface, but at the end of the day, with a chat prompt, all I need is a question to start. What services are currently running in production? For each service, what are the top operations that they handle? For each operation, what performance characteristics do they exhibit? This is all information that can be captured just through asking a simple question. And for our ecosystem, we can tailor the deployment to work on a very narrow set of capabilities. So we can deploy a custom MCP tool set that is very particular to the solution that we're trying to address. We can use Ollama to host a small language model on edge infrastructure instead of needing to leverage these large models that are quite often resource constrained. And if we really wanted to, we could sit down and replace each of these different components with some other alternative, depending on what we were looking for. In the case of model serving, maybe we need to split a model across multiple GPUs. So VLLM is a great choice for that option. NAN or NAN is another great low-code workflow option for being able to wire up your entire agent process. If you're using more of a RAG-based solution, you're probably using something more like Weave8 instead of your MCP toolchain. All of these are just means to augment your existing chat ecosystem. Now, when it comes to the actual data exploration process itself, I tend to look for a desired iteration loop where I can ask the client a very basic question. Using pre-built discovery tools, the client is able to build its own context, like listing the tables available, describing each of the tables, and then start constructing some sample queries to be able to better understand what information is stored in each of those. you will likely go through a iteration source or an iteration cycle where you test one query, you go back, you expand it, you build more capabilities on top of it, and then you test it again. You want to be able to evaluate the performance at each stage of that game. Once we finally have a query that we're happy with, we might want to offload that into our source repository and spin up a new MCP tool using something like Google's Gen AI Toolbox, or maybe save it as a SQL file that we might pull into a program later on. To give you a little bit of an idea in terms of what each of these functions do, you can get a basic idea with show tables and the show create table operations in MySQL. Similarly, we can break that down and think about what a explain and an execute statement might look like. And then finally, we can think about, well, if I was to think about that top operations command, I might use AI to sit down and iterate towards a working statement where we now have a function that can be defined that gives us the ability to just interpolate start and end and return all of the top operations for all services or a given service. And this entire endpoint can be customized to what you want it to use. Similarly, we can fetch performance characteristics like the 95th percentile or the 99th percentile and provide similar reporting and capabilities back to callers of this MCP tool. Finally, I want to leave you with some thoughts and considerations. First, be mindful of your audience and the harm that your tools can potentially cause. Being able to invoke any old SQL statement is going to have performance considerations on your backend infrastructure. So working with well-known, well-specified tools can quite often be a lot better than working with overly generic tools. Be sure to document your database schemas, right? When you're describing a table, you're not just getting the field names and the types back. You're getting the comments back, which offer additional context for your LLMs to take into consideration. Plus, you're making it easier for people coming after you to understand what that database table and field represents. And then finally, there's a lot of cases where we have these JSON blobs stored in schema. Specifically in OTel, we have the resource attributes and span attributes fields that are large blobs within the each individual datum, because technically it's not a row. So make sure you're documenting each and every one of those. It will help provide your LLM additional context throughout its entire time constructing and working with you on query iteration. And then finally, for Mac OS X users specifically, if you're not using KRunKit yet, go take a look at it. It integrates really well with Podman and gives you more native container performance on OS X. It really gives you, the biggest thing I've found is it gives you the ability to tap into GPU resources, which I've struggled with on some of the other platforms. Anyway, thank you all, and I look forward to hearing from you.